Day 8 is over, and it's time to make a report video about what did I learn today. So today was nice. Today I learned a lot of information about chemistry, about periodic table. We've learned some new elements from it, and we also studied solid waste management and the feces treatment. So I'll go first with chemistry, and as I mentioned, we have learned very cool elements, the most popular elements in the periodic table, such as ozone, O3. Which is responsible for our ozone layer, and that's the reason why the Earth has that pale blue color. Pale blue dot. And it turns out it's a poisonous gas with a sharp odor, and we can use it to kill some sort of bacteria in water. By the way, today we also went through some pretty important acids, such as sulfuric acids, but I'll come to that topic later on. Now I would love to talk about oxides. So we have peroxides and superoxides, and acidic anoxides. I have no idea about the acidic anoxides, but I do have some about peroxides. So peroxides are formed with cations of four elements: Na, Ca, Sr, and Ba. I don't know the names. Right now I don't know the names, but I will Google it after. And hydrogen peroxide, for example, H2O2, is very reactive. And it's disproportionate. It means the same molecules can make different results, different materials. So that's what we call disproportionate. And superoxide ions, O2 with a negative power, formed with most active metals. The next element for today is sulfur in nature, that yellow powder. So it turns out sulfur is one of the key components in industrial use, just because it's very you can create really strong acids with it, like sulfuric acid. But the only problem is it's a bit poisonous. Not a bit, but it is pretty much poisonous. But there are some ways to treat it. But we'll talk about it tomorrow. Sulfuric acid. The production of sulfuric acid. Since it's an extremely it's very strong acid, it's often used in industrial purposes, and it has sulfides and disulfides. Sulfide is sulfur in the -2 oxidation state. I have no idea what does it mean, but it's written, so I guess I'll have to Google that too. And SO2 is a poison to SO2, sulfuric oxide dioxide, is a poison to lower organisms. I think it can be used for domestic use, just to kill some bacteria, just for the cleaning purposes, and so on. but I'll come to that later. And nitrogen, which is 78% of the Earth's atmosphere. The sources of nitrogen are nitrate salts, and the most important use of nitrogen is to make fertilizers. It turns out the best use for the nitrogen is for fertilizers. They're supposed to be fertilizers, good fertilizers. And it can be liquefied. It's usually used in different cases. For example, if you want to keep bacteria, you can use the liquid nitrogen, or maybe if you want to show off in a restaurant, like in some fancy restaurants, you can order some special food, and they'll bring it with that liquid nitrogen. So, but it looks cool. And it's pretty cold, like minus 196 degrees Celsius, something like that. And oxy acid, we also learned about oxy acids and oxy acids of nitrogen. For example, nitric acid and HNO3, which is a pretty strong oxidizing acid, important for industrial compounds. So because of this thing, it's often used in industrial use. Nitrous acid, and we also have nitrous acid, which is HNHO2, which is not that strong. It's less stable and it's pretty weak. It's a weak acid. So, but there are some certain cases where we can use them too. And the next element for today is phosphorus. The source for phosphorus is phosphate minerals, and and there are some types of phosphorus. For example, allotropes, not types but allotropes. So there are two allotropes for phosphorus. The first one is white phosphorus, and the Pu, by the way, P4, and red phosphorus, which is just P. By the way, the red phosphorus is more stable, and the white phosphorus can burst into flame when it contacts with oxygen in the air. So that's basically it for the phosphorus. And not the end. We also have oxy compounds of phosphorus, such as phosphorus oxide, P4O6, and phosphorus oxide 5, like P4O10. No, not O6, but O10. So those are anhydride forms of phosphorus, and they usually those components usually used to dry the experiment environment from water or from any other liquid. And by the way, the same thing can be done with using silicones, for drying, but using phosphorus is more expensive, but at the same time it's more it's better, but more expensive. So we can use silicones, it's okay. The next element for today is carbon. Well, probably the most popular, the most special element in the world, carbon. So it can be found in graphite or diamonds, for example. Yeah, and oxides of carbon. Carbon monoxide, CO, probably the most important and the most popular one, which is colorless, odorless, and tasteless gas, CO. It's usually used as a fuel and as a reducing agent in metallurgy, but since it's a poisonous stuff, people do not usually like to use it in the metallurgy, but it's a fuel. Yeah, it is a fuel. Carbon dioxide, of course, carbon dioxide, everybody knows about it. CO2, which is colorless, odorless gas, and it plays a major role in the greenhouse gases. And where does it come from? It comes from carbonated beverages. I think that's just one source of it, and there should be more. And carbonic acid and carbonates. Carbides. What does it mean? Carbides. I have no idea. There's an explanation. Binary compounds of carbon and a metal, metalloid, or certain non-metals. For example, calcium carbide. Material from carbide are heat resistant. That's an extra information. Also, and also there is a silicon, the next element for today. And silicon turns out to be the second most abundant element in the world, in the Earth's crust, and it occurs as SiO2 and from silicate minerals. It's a good a semiconductor. So a semiconductor can be produced with silicon, and it's usually used in making transistors and solar cells. But it needs to be a pure silicon. But how to get that pure silicon? Well, there is a thing called zone refining. Zone refining. So it's a special process for purification. It looks something like this. But it's pretty slow. The zone refining is a pretty slow process, and it takes some time. That's it for the silicon. And the next element for today is boron. Boron is the only non-metal in a group 3A, and boron is very special because of its bonding capabilities. Boron compounds of boron and hydrogen, for example, the simplest B2H6, special to create different bonding systems. So there is something special in the bonding system of boron. I'm still trying to understand that idea, but if I got it right, because of that bonding, some special molecules can be created. So that makes boron so special. And it has something to do with its electrons. I think it needs more electrons, or maybe less electrons. I don't know. I'll learn it later on. So that was it for the chemistry. Yeah, and now I would love to talk a bit about solid waste management. So today we have learned pyrolysis that people usually call it as retorting in industry or thermal decomposition technology. Yeah, and it's pretty much related to incineration, but there are some major differences between incineration and pyrolysis. So it basically means turning some plastic or some other waste into the fuel, into useful fuel, such as oil or gas. So, oh, by the way, about the incineration, there is a problem with incineration. It turns out it can lead to dioxin. It's a dangerous gas, like very dangerous gas, dioxin. By using plastic, for example. Oh, and pyrolysis is more promising than combustion. Yep, that's a good thing to remember. And the temperature in the pyrolysis system is between 600 and 700 degrees Celsius. That's enough to turn waste tires, for example, or plastics into an oil, like heavy oil. So yeah, that was the basic understanding of pyrolysis, but I will search on it further, and I hope I'll get the whole idea of pyrolysis. Now it's time for the physics treatment, and today we learned how to treat excreta thermophilic digestion. So basically it's storing the feces under the high temperatures, I think from 53 to 55 degrees for 14 days, for 2 weeks, or composting aerated piles for 1 month. So those two processes basically have the same result, but the first case takes only 14 days, and in the second case it takes for 1 month and at a different temperature. I mean, composting aerated piles for 1 month, we keep feces under the pressure. We store it and keep the temperature between 55 and 60 degrees. But it can take even longer, from 2 to 4 months for the further maturation. So these two processes are recommended and generally accepted procedures, which are widely used whole around the world. And we finally learned the difference between anaerobic procedure and the 4 steps of anaerobic procedure and aerobic procedure. So I'll start with anaerobic process. That means without the oxygen, the process that does not need oxygen. yeah, it has 4 steps. The first step is hydrolysis, it means desorption. The second step is acidification. The third step is getting the protein or methane from the biogas, and the fourth step is treating that biogas, treating the methane, to make sure that we get rid of to make sure that we can upgrade it and get rid of and get the pure methane, I think from 16 to 19%. So basically, throughout the procedure, after the procedure, it will have 4 elements, which is CH4, methane, CO2, carbon dioxide, H2O, and H2S. So these last H2O and H2S should not be there, so they should be removed in order to get the pure methane. And that process of removing those 2 elements is called upgrading. Yeah, that's it for the anaerobic process of biogas. And let's move to aerobic bioprocess. Aerobic means it needs an oxygen, it needs an air, but where to get that air? Well, usually we can leave the source in an open air, or there is a blower system and air pressure. And these 2 are the most common in the world. And also we can add some pure oxygen as well. So, and we also learned something about composting. Composting, it turns out it's really, when composting, it's very important to keep the temperature between, for example, between 55 and 60 degrees Celsius. But it's gonna take a lot of time, so it takes for about 3 months. So the room for composting should be very, very big, right? In order to effectively treat the feces. By the way, I'm still talking about the feces treatment. Yeah. So composting in a nutshell. So for separately collected fecal material, composting is a natural process, and when composting, CN ratio, the most important things to mention is CN ratio, the moisture content, aeration. So all those things need to be appropriate to let the temperature rise. And as I said before, the temperature, it's very important to keep the temperature high, between 55 and 60 degrees. We need higher temperatures for better composting. Also, sometimes we can add active waste such as kitchen waste or acids. Those are recommended for a big scale composting. And what if the environment itself does not let to rise the temperature? Well, then there is a thing called greenhouse composting units. So those are literally little houses just built just for composting, and those are usually placed in the cold areas, usually during the winter or so on. And that's it. We also learned something about ashes, the treating feces with plant ashes. So it turns out when we mix plant ash with feces in ratio 1:3 and yield a, yeah, it decreases the pH level, like it decreases a lot, and yeah, it's all about the reduction of phages. Yeah, that's it for composting. That's it for feces treatment. And yeah, as I told before, the feces treatment is all about removing pathogens, but this time I learned that it also can be used as a good fertilizer after the composting procedure, which might be pretty complicated sometimes, but at the same time the idea is simple: to keep it with high temperature. So unfortunately today I did not have enough time to learn Chinese. Hopefully I'll do it tomorrow. Anyway, that's it for today, and I'll see myself tomorrow.